Hey, what's up guys? This is Gary and I'm here to bring you Hot Boys Garage episode 18, where I'm going to show you how to bench test a Stator out of a 2004-2005 Honda TRX450R. Alright, so first up, what is a Stator? It's pretty much a bunch of coils with windings on them. And one out of a first generation Honda TRX450R quad looks like this. It's on the left side, driver's side of the engine, and it lives pretty much inside the flywheel. And with the flywheel rotating around it, that's how it develops power. And that power is produced in an AC signal, which is later turned into a DC signal to power most everything on the bike. This black piece right here is the pickup, and then everything the Stator does is transmitted to the rest of the bike through these three connectors. So you might be wondering, why would I ever want to bench test a Stator? Well, for me, the answer to that is it's a quick and cheap way to test out a Stator. You can do it with the Stator mounted on the bike already, or you can do it on the bench like I'm going to show you how to do today. And really all you need is a cheap little digital multimeter like I've got here. I picked this thing up for about 30 bucks on Amazon. So let's jump into it. First, we'll set up the multimeter. It should have two leads. The black one should be plugged into the COM port, and the red one should be plugged into the voltage / ohms / milliamps / volume port. You don't want the red one to be plugged into the amperage port. And we're going to do two different types of tests. And for both of them, our leads are going to stay plugged into the same two ports. Our first test is going to be just for a simple testing of continuity. And for that, you want to turn the dial to this guy here, which is a little sound beepy guy. And in the resting mode, it should say OL, which is open line. Then after that, we're going to be testing for actual resistance. And that's measured in ohms. So we'll turn the dial to this little symbol here, right there, which is the omega symbol. And again, in that resting state, should be open line. Now again, these are just two simple tests that you can do with a cheap multimeter. You're pretty much checking for resistance in the wires, continuity, and to make sure there's no shorts. Now, a better test is always going to be a dynamic test with the machine running, and for that you'll need a much more expensive multimeter that will actually measure peak voltage. But for your average weekend warrior, this is a pretty good test. Alright, so for the actual test, I'm going to try to run through these pretty quickly. Alright, first up we've got our black 2-prong connector. There is a green wire and a blue and yellow wire. And this connector is the one that the bike uses for the ignition to read the crank position. So it's the ignition / pulse coil circuit. So first up, to test the continuity, we'll set our multimeter to the sound setting, and then we'll take our two leads. It doesn't matter which one goes where, and we'll touch metal to metal for the two leads inside there, and we should not hear a beep. Also, we can test to make sure there's no shorts, and we'll stick one lead down inside the connector on one side and touch the other connector to the metal base of the Stator, and we should not hear a beep. And we'll do the same thing on the other side of the connector. We should not hear a beep. Next, we'll check the same connector for resistance, set our multimeter to ohms, and we'll take a reading between the two, and that'll give us a resistance reading on the screen measured in ohms. And then in the same token, we can also check for resistance via shorts back to the base. This should always say open line. Do the other side. And we'll do each of the connectors just like that. Next up, we've got this 3-prong connector. It's kind of clear-ish. There is a red and black wire, a blue wire, and a white wire. Red and black's on the outside, white's on the outside, and blue is in the middle. And this one is the exciter coil. It's responsible for charging and powering the CDI with AC current. So to test it, we're going to do the same thing. First up, we'll check for continuity. Multimeter set to our sound beep. For this one, we should get a beep between all three. So we're going to go outside to outside, inside to right, and inside to left. We'll also check for shorts, running each back to the Stator mounting piece. We should get no beeps, no shorts. Test each of the three. Then we'll move on to our resistance test, setting our multimeter back to ohms. First we'll do our black and red to white, then our white to blue, and then our blue to the black and red. And the last one we're going to do is this big gray plug. It's got 3 yellow wires running to it. This is the charging circuit. The power from it goes to the rectifier, and it's converted to DC power for pretty much everything else on the bike. And I'm not going to bore you guys with showing how to test this. It's the same method, same settings. When testing between the three, outer to outer, inner to left, inner to right, you should get a beep for continuity between all of those. And then going from each one back to the stator, you should get no beeps. And then your resistance between each of them should be between 0.1 and 1.0. And we're going to go over the specs for each here in just a minute. All right, so now that you know how to test your stator, you're probably wondering what readings are bad, what are good. And I was wondering the same. So the test for continuity, where we're just checking for beeps, that's like a yes or no, and that's pretty simple. But the test for resistance, where we're seeing a measurement in ohms, I went to the manual to look for specs on that. And the only thing that I found in the manual, at least for a 0405 TRX450R, was for that big gray 3-prong charging circuit. And the spec for that was between 0.1 and 1.0 ohms. And that was for all three. That's inner to outer and outer to outer. And so I looked around online, I asked some friends, and nobody could really give me any spec on the ignition circuit or the exciter circuit. So I've got a lot of stators here. Some are installed in bikes, some are spares, but the whole driving force behind this video is I got another engine for the little bike. It came with a stator that I wasn't sure if it was good or not. So as a first step, I figured I'd bench test it. So what I'm going to do is I'm going to go ahead and bench test that unit, as well as 4 other known good stators and 1 other bad stator. I'm going to throw all those readings up on the whiteboard, then I'll average them and we'll go over them. That way, if you're testing your stator at home and you get a resistance reading and you're not sure if it's good or not, at the very least, at least you could look back at this and see where all of these stators fell. So fast forward, I'm going to do that. Okay, so here is a screenshot of a spreadsheet that I put together for all of my stator testing results. It was way easier to do this like via screenshot because it is a lot of data. And so hopefully you can take a look at this, pause the video if you want to see the details. And then so I'm going to take this data and do some averages, highs, lows, and put it on the whiteboard for this next shot. Okay, here is a table on the whiteboard that I put together that shows the resistance on each circuit between each wire. You got average, high, low, and the sample size. Take from this what you will. Hopefully this will let you know if you are in the ballpark for your readings. So that's it for this episode. Hopefully it was informative. Hopefully you learned something. In between episodes, you can follow me on Instagram at Hott Boys Racing with 2 T's, as well as check out our ATV drag racing page on Facebook. You can just search for Hott Boys Racing with 2 T's. And I'll also stick links to both of those in the video description. Stay tuned for more content, and thanks for watching.